like I say, spacer ways, weighted on hand and foot by robots. All right, 2.7, we're solving linear inequalities. A linear inequality is the form ax plus b less than c, or greater than c, or less than or equal to c, or greater than or equal to c. If it was an equality sign in the middle, then it would be a linear inequality, a linear equality. But here we replace that sign with either a less than sign, or a greater than sign, or less than or equal sign, or a greater than or equal sign. Now, a solution of a linear inequality would be something like one of these forms: x less than a, or x bigger than a, or x less than or equal to a, or x greater than or equal to a. These are inequalities. The less than a has a graph. It consists of the left half of the line, everything to the left of, but not including a. I denote that by having an open circle at a. Now this is also, there's an interval notation, negative infinity to a. So it goes from minus infinity to a, not including either endpoint. X greater than a consists of all the points to the right of a and not equaling a. So we denote that interval by round bracket a to plus infinity round bracket. These are both called open half lines. I mean, they're half the line, and open because it doesn't include the endpoint. Now, for closed half lines, we have less than or equal or greater than or equal. S less than or equal to a consists of all the numbers less than a and possibly including a. So I denote that by a solid point at a, and also denote it by round bracket negative infinity to a square bracket. Square bracket for closed, round bracket for open. X greater than or equal to a consists of all the points to the right of a or including a. So square bracket a to positive infinity, and I can see that I didn't have a round bracket at the infinity, so should be changing that soon. Okay, so you solve linear inequality by turning into a half line. We'll use these rules, which is sort of like the transposition rules, but with a little bit of a change for one set of operations. If a is less than b, then you can add c to both sides and subtract c to both sides. You do it with less than or equal, and greater than. So if you have two numbers in order, then you can move them to the right, move them to the left, and they'll stay in the same order. Now here we have multiplication. It gets a little complicated. If a is less than b and c is positive, greater than 0, then a times c is less than b times c, and a divided by c is less than b divided by c. So multiplying by a positive or dividing by a positive preserves the order. If you're this way, then you double them, it's like this. You half them, it's like that, they'll still be in the same order. If a is less than b and c is negative, less than 0, well, then a times c is greater than b times c, a over c is greater than b over c. So multiplying or dividing by a negative number reverses order. Less than becomes greater than, or vice versa. Times negative and divide by negative reverse order. So that's a small detail of these things. So we'll do some examples. All right, now here we have some inequalities to solve in graph. X plus 2 is greater than 5. All right, to solve it, we subtract 2 from both sides. And that keeps the inequality the same direction. So x is greater than 5 minus 2. So x is greater than 3. That's the inequality. It's the right half of the line, not including 3. We denote that by the interval from 3 to infinity, round bracket at both ends. Here we have g minus 30 is greater than or equal to negative 20. Okay, we isolate g by adding 30 to both sides. That'll cancel this negative 30, and it keeps the inequality the same. So g is greater than or equal to negative 20 plus 30. So g is greater than or equal to 10. It's the right half of the line, including 10, square bracket 10 to infinity. Here,
sorry.
Oh, I love it. Go ahead. With what?
So the open circle is only when it's not, there's not an equal bar under it, right?
Right. For strict inequality, strictly greater than or strictly less than, you have an open circle and a round bracket. For a greater than or equal or less than or equal, then we have a filled circle and a square bracket. Okay? All right, we proceed. Now here, negative 13/16 x is greater than or equal to negative 9. Now, we can get rid of this by multiplying by the reciprocal, negative 16 over 3. But because it's negative, that will flip this inequality from a greater than or equal to a less than or equal. So we get x less than or equal to negative 16/3 times negative 9, which works out to x is less than or equal to 48. That's a left half line, left closed half line, everything to the left of 48 and inclusive 48. And the interval notation is round bracket minus infinity to 48 square bracket. All right, here's another one with a negative sign. Minus 3y is less than or equal to negative 6. So we divide by a negative 3. That flips the inequality sign. So it's y is greater than or equal to negative 6 over negative 3. So it's y greater than or equal to 2. It's a right half line, including 2 and everything to the right of it. Square bracket 2 to infinity. Here we have 8h is less than 48. All right, so we get rid of the 8 by dividing both sides by 8. It's a positive number, so the inequality stays the same. To get h is less than 48 over 8, which works out to h less than 6. Left half line excluding 6. Round bracket negative infinity to 6. Round bracket. Now we're going to have to do several of these operations in a row. Here we go. A half plus n over 5 is greater than 3/4. All right, I don't like the denominators, 2, 5, and 4. So let's get rid of them by multiplying throughout by the lowest common multiple of 2, 5, and 4. That's 20. So, okay, and because this is positive, the inequality sign stays the same. 20 over 2 plus 20n over 5 is greater than 3 times 20 over 4. After some cancellations, that becomes 10 plus 4n is greater than 15. All right, we subtract 10 from both sides. Ooh. Okay. Subtract 10 from both sides. That keeps the inequality the same. So 4n is greater than 15 minus 10. So therefore 4n is greater than 5. We divide both sides by 4, and 4 is positive, so it keeps the inequality the same. N is greater than 5/4. Orderless, right? All right. Okay, n greater than 5/4. Its graph is this half line, not including 5/4, but everything to the right of it. Round bracket 5/4 infinity. It's the interval notation. Now we have something called a double inequality. 3 less than or equal to 2x minus 1 is less than 5. So it means that 3 is less than or equal to 2x minus 1, and 2x minus 1 is less than 5. So 2x minus 5 is between these two numbers. Now, okay, so we're going to isolate x, and the thing to do is to add 1 to all three parts. So get 3 plus 1, 2x in the middle, 5 plus 1 here, and adding anything will keep the inequalities the same. So you have a less than or equal here, and a less than here. So here we go. 4 less than or equal to 2x is less than 6. We divide all three parts by 2, get an x in the middle, 4 halves, 6 halves. Because we're dividing by a positive number, that means the inequalities stay the same. So 4 halves less than or equal to x, less than 6 halves. So that works out to 2 less than or equal to x, less than 3. And so this is known as a half open interval. It includes 2, excludes 3, and it includes everything in between. The interval notation is this: round square bracket 2 to 3 round bracket. It indicates that it's everything in between. Square means that it includes 2. The round means it excludes 3. Oh my goodness, I think a hair got into the scanner. All right, here we have a similar thing. 6 less than negative 2 times x minus 1 is less than 12. Now, okay, watch out. We want to get rid of this negative 2. So to do that, we divide throughout by negative 2. But that will reverse all the inequalities from less than to greater than. To get 6 over negative 2 is greater than x minus 1, is greater than 12 over negative 2. So negative 3 is greater than x minus 1 is greater than negative 6. We clear away this 1 by adding it to all three parts. And adding anything keeps the inequalities the same. Greater, 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 greater. So you get minus 3 plus 1 is greater than x is greater than negative 6 plus 1. That becomes negative 2 is greater than x is greater than negative 5. Now this is okay as an answer, but personally I prefer to use less than signs because that way it lays on the page the way it lays on the line. So if 2 is greater than x, that is greater than -5, then you flip them, you flip them all over, you get -5 is less than x is less than -2. So okay, so we get -5, machine. -5 is less than x is less than -2. Here's the open interval. Open interval if it doesn't include either endpoint. Between -5 and -2 and not including the endpoints. The notation for that is -5, round bracket, -5, -2, round bracket. Now here we're going to have, here's another double inequality. Y over 8 minus 4 is between -8 and 2. So let's first transpose the 4. Add 4 to all three parts. So you get -8 plus 4, y over 8, 2 plus 4. Adding anything keeps the inequality signs the same. And so we have -4 less than or equal to y over 8 is less than 6. Now to get rid of this 8 here, we'll multiply all three parts by 8. Get -4 times 8, y, and 6 times 8. And since we're multiplying by a positive number, these inequality signs stay the same. So this works out to -32 is less than or equal to y is less than or equal to 48. So it's a closed interval. It includes both endpoints. From -2 to 48 inclusive. So it's denoted by square bracket, -32, 48 square bracket. Someone should mute. Okay, whatever. All right, now 99AB, these are one of these ones that they do similar things. Here we have a greater than sign, here I have an equal sign. So all the operations here we can repeat here and get an equality rather than an inequality. 3/8 plus b/3 is greater than 5/12. All right, 8, 3, and 12 have a lowest common multiple of 24. So we multiply throughout by 24. Since it's positive, it keeps the inequality sign the same. 24 times 3 over 8 plus 24b over 3 is greater than 24 times 5 over 12. All right, after reducing this, 24 times 3 over 8, that's 9. 24b over 3, that's 8b. 24 times 5 over 12 is 10. So 9 plus 8b is greater than 10. Transpose the 9 by subtracting it from both sides. 8b greater than 10 minus 9, greater than because the inequality sign stays the same. 8b is bigger than 1. Now to isolate b, we have to divide both sides by 8, a positive number, so it keeps the inequality sign the same. b is greater than 1/8, so the graph is of the right half line, excluding 1/8, denoted round bracket 1/8 to infinity round bracket. Now 99b is the same thing with an equal sign instead of a greater than sign. So if you just go through all the same operations, so instead of b greater than 1/8, it's b equals 1/8. Similar problem. All right. Is that it? Hold on. Oh no, one more. All right. Just a second. Yeah. 101A and B have, here's a single inequality, here's a double inequality. All right, here we go. 4 less than or equal to 2x minus 6. We clear away the 6 by adding 6 to both sides. That keeps the inequality the same. 4 plus 6 is less than or equal to 2x. So this becomes 10 is less than or equal to 2x. We clear away the 2 by dividing throughout by 2. 2 is positive, so the less than sign stays a less than sign. At 10 over 2 is less than or equal to x. 5 is less than or equal to x. So x is at least 5. A graph is everything to the right of and including 5. Square bracket 5 to infinity. Now for this one, we had another inequality. So 2x minus 6 is greater than or equal to 4, but strictly less than 18. So we do a lot of the same operations. First, we'll add 6 to all three parts. Turn this 2x minus 6 into a 2x. The inequalities stay the same. The less than or equal remains less than or equal. Strictly less than remains strictly less than. We get 4 plus 6, less than or equal to 2x, less than 18 plus 6. No, 10 is less than or equal to 2x is less than 24. Now to clear away this 2 here, we divide throughout all 3 parts by 2. That's a positive number, so again, the inequality signs remain what they are. So you get 10 halves, less than or equal to x, less than or equal to 24 halves. So 5 is less than or equal to x is less than 12. It's what's called a half open interval. Open at the 12 end, closed at the 5 end, including 5, excluding 12, and including all the numbers in between. The notation for this is square bracket 5 to 12 round bracket. All right. That concludes this part, and now I shall stop the recording for this.